unit activity. So this I am going to skim over. So it's going to be a fairly short video, but I do kind of want to get into how to do this. I've seen a lot of people struggle with what's necessary for this activity. So again, I'm not going to put the answers on here for you to copy. It is a graded activity. So what we're going to do here is try to get as much of this done as possible. So when we're going to be talking about volume and density, and here you can see a picture of the Titanic. It'll make a little more sense after a while of what we're talking about here. So again, I don't know if I've covered this in previous videos, but these are the grading criteria. Usually what I do is I copy and paste this and write down comments on how to fix it. But let's get into the actual lesson itself. So in order to solve for density, the idea of density is how much stuff there is in an object. So when we're talking about density, we need the volume of something. So you see, we've done it throughout this entire unit, how to do volume. So volume is how much space something takes up. Mass is weight. It's usually done more accurately. Mass should be in kilograms, but they're doing it as a form of weight in this for this project. And we don't need to get into the physics of it, but we do need to know that mass is basically weight. So we're doing the weight divided by the volume. So in this project, we're going to be talking about how much space stuff takes up. So when we're looking at this, we're talking about volume. So what is the density of a volume? This is an example of it. In this case, we're finding the density of volume of a candle and objects. So this one, we're measuring the candle for a cylinder and stuff and just figuring that out. Now let's use density in a way we can see it. So Harold's a woodworker. So he's a woodworker. He has two different types of wood. One of them is a pine log. So let's kind of make sure we get that separate. So one of them's a pine log that has a 40 centimeter radius or 5 centimeter radius and is 30 inches long. The other one we're going to write down is and the weight of this log is this much. So we're going to need all that information together. 42.6 pounds. We're going to need that later. The other thing is an oak board. So this board that's made of oak has a width of 0.5 inches. It has a thickness of 1.5, and it's 5 feet long. All right. So we need to describe this. So if we're thinking of a log, what is a log? Well, a log, so the pine log is a cylinder. So we've gone over cylinders in the past videos for the first unit, I believe. So a pine log is a cylinder. They don't ask us to do it in this. However, it is a good idea to measure the volume right now. But the way they're asking this, I'm not going to answer that right now. So the pine log is a cylinder. And what was it? The oak board is a rectangular prism. Or you could just say prism, but the main idea is that it's a rectangular prism. It's very easy to see that. They kind of go into this in more detail on their answers. Again, you don't have to do that, but you will kind of have to do it when you're talking about the pine log. So in order to figure out the density, of the pine log, so we have to find the volume first. So in order to find the volume, so to find the volume of the pine log, we use the formula. And I'm going to use the equation editor just to plug it in. I recommend it that way we can use these powers. Volume equals pi. Oops, I don't know how I got a C. Oh, I guess because it's right next to V. Volume equals pi r, going to use this exponent, squared times height. So in this case, for this one, it's going to be pi. We're going to need our radius. Our radius is 5 inches. So 5 squared. And the height was, I believe it was 30. Let me double check on that. So if we look at this, it's going to be 30 inches. This is going to be equal to, I'm going to use the Desmos calculator for this. So by showing your work, it basically means show your formula and then show your answer. Don't just give us the answer. Let's go into Desmos. I'm going to use a scientific calculator to make this easier. What I like about Desmos is you can literally type in pi and it knows you're talking about pi. I'm going to do 5. If you don't like doing shift 6 to get that little caret, you can always hit the little squared button here. And then we're going to do 30 in parentheses. And we're going to end up getting this 2356. I'm going to do 0.19 just to cover my bases. So my volume ends up being 2356.19. Now I need to do my formula for density. So density equals, I'm going to put the little thing here, mass divided by volume. And this is going to be our mass. So our mass is 42.63. So we're going to write 42.63. And our volume is going to be 2356.19. And this is cubic inches. You want to make sure all of your units are the same. So the radius was inches, we squared it. This was inches, so it becomes inches squared. All right. So let's figure this out. So we're going to grab our calculator. And when we get our calculator, we're going to do 42.63 divided by 2353.19. And I end up getting 0.018. So I get 0.018. And this is technically pounds per cubic inch. So if I wanted to do that, it would be LBS inches cubed. If you want to do that, I'm not requiring you to do that. It's just helpful to know how we're doing it. So that's the main thing on how we're solving for the density of this. So I just wanted to give you guys part B on how to do this. The board is significantly easier. I'm going to let you guys do that on your own. So to do the board, we have to do the formula volume equals length times width times height. The only tricky part about this is keep in mind that they said 5 feet or 3 feet long. So the only thing I'm going to ask you guys to change is when you're looking at length, do not type in that 3. We want that in inches. So you're going to want to change your length to 3 times 12 inches because that's how many inches are in a foot. Then plug in your width, plug in your height, and that'll give you your volume. After that, everything else is the same because we still have it in pounds. So we want it pounds per square inch. So you want to make sure that you're going to do your mass divided by your volume for the next step for density. So let me erase that. That looks terrible. So when you're doing this, you're going to want to make sure its density is equal to your mass over your volume, and then plug those values in. That way you get your density. And I recommend going like 3 decimal places, including the 0 in this case. So that'll help you do that. All right, so going into the next one, if you were asked to describe it and they were the same shape, what would the weights be? So in this one, you should really be talking about the density. So if they were the same shape, they say it all fancy, like same dimension, same shape. How would they compare? Well, if they were the same shape, same dimension, same everything, whatever has the highest density would be heavier. And you should explain that too. In your explanation, you should write, because I don't know which one of these had the higher density. I'm sure you can see just by the video feed, but please show your own work. Which one has the higher density? You're going to say, well, since blah, blah, blah has the higher density, the if the log and the board were the same shape, it whichever one would be more whichever one would be higher. So let's say you had, let's say for example, the pine had a greater density than the oak, then you would say the pine would weigh more. But let's say if the oak was greater than the pine, you would say the pine would have the greater density. All right. And please use your own words. Don't just copy what's on here. Water has a density of this. So that you might know that wood floats in water. What can you conclude from the densities of this? So you would have to say whichever ones were lighter. So if both of them are lighter, since both of the woods are lighter, they would both float. So if both of them were lighter, if only one of them's lighter, tell me which one was lighter. Use your own words, and write which one is lighter because of that. So review what you got for A and B and talk about that. All right. So let's move on to the next part of this. So the next part of this, Archimedes. So please read the story. It's actually pretty interesting. How he discovers it. But the main idea that we find out about this is the idea that he finds out that, hey, I take up a certain amount of space, so that's going to displace the water. So this one, you should be writing about that idea of displacement, of um, how water or how things take up space and stuff like that. So what's the key idea here? Mention that somewhere in there, the idea of displacement. We're also going to be talking about a gold crown. So make sure you're reading all of this up and talk about how gold is denser than silver. So that idea, keep in mind, if gold is denser than silver, then gold should take up less space per weight. So those are concepts and ideas you should be writing about in this, and explain yourself using your own words. Like I mentioned before, this is a graded assignment. Don't just copy the answers. Use your own words and talk about it, read it, and explain. And it should involve these ideas that um, if the crown weighs the same, then there's going to be more gold because you need more gold to make up for the weight in, or you need more silver. I'm so sorry. I misspoke. Since silver has less density, you need more silver to make up for the weight of gold. All right. That one was a big reading one. So now we're going to be talking about displacement. So when we talk about this buoyancy force thing, buoyancy is basically talking about this force of water. So making sure Archimedes' principle of displacement and buoyancy uh, explain why some objects float. So obviously, if something is uh, less dense than water, you can't really get all that volume out of the way because it's less dense. It ends up floating because there's not enough force to counteract this buoyancy force. So something about that, like read the story, it builds on this. So basically, because there's not enough uh, density on there, it ends up not floating. So now we're going to talk about the Titanic, the ships. So search the internet to determine the weight in metric tons. This is a very simple thing. There's not much else to do. You just look it up online and you get the answer. So they say about that much. I think this is not loaded. Oh, when it wasn't loaded. So you're going to go on Google. So let me open up another tab. And you're just going to type in weight of unloaded Titanic. All right. And they want it in metric tons. Weight of unloaded Titanic in metric tons. All right. So this one, we want metric tons. So weight, gross displacement, a displacement of this, click the. I'm just going to do this. Titanic. I'm not finding an answer I like. Titanic weight in metric tons. Okay, here we go. It's about wide a gross weight of that many tons. So it's gonna be about 40,000 metric tons. Again, sources kind of give you different answers. They're putting it at approximately 46,000 metric tons, but you can see I found the source at a different thing. So just write this down because you will have to show your work later, and that kind of affects it. So we're going to write down the hull of the ship was the only portion of the boat that touches the water. So this is the only thing that's displacing the water. Therefore, how many tons of seawater should displace? So are we supposed to be looking at searching internet? So whatever you put here should be the same. So uh, since it since the Titanic floated, the minimum weight of water displaced should be, so it should be whatever you put here because that much water has to get out of the way. I'm using like hand gestures, but basically what's happening is we have this boat. Oh my gosh. We have this boat and it weighs a certain amount. So the hull of the ship is down here. The whole weight of the boat has to displace that much water. So we have to get rid of that much water. So what's happening is you have all this weight of the boat going down. So that much buoyancy force should be going up to displace it. So basically, that's a long winded way of saying like that answer should be the same. Like minimum, whatever you found. And this number, as you saw, varies. I got a completely different number than what Edmentum's telling me. Next, we have to search in the for the density of water. All right. So we're gonna look up the density of seawater. So density of seawater. The density of seawater. Do they want it in a specific way? kilograms per cubic meter. So they want it. So density of seawater in kilograms per cubic meter. So we're going to get 1,200.6 kilograms per cubic meter. All right, cool. So that's actually exactly what they got. Well, not exactly. There's some differences there. So it is going to vary. Now, here's the thing. We need to convert the density of seawater to metric tons per cubic meter. Well, luckily we already have it there. So what we need to do is we need to take this number. I'm going to take the number they got. And this is in kilograms per cubic meter. So basically what we need to do is we need to change kilograms to we need to change it to metric tons. So we're going to Google how to turn kilograms into metric tons. So how many kilograms are in a metric ton? So 1 metric ton equals 10,000 kilograms. So we're going to take this number. Let me delete this. Go to my equation editor. We're going to take this number, whatever we got, and we're going to divide it by 1,000. And the reason for this is if there's 1,000 kilograms in a metric ton, then metric ton should be this. We basically just moved the decimal place over. If you guys don't believe me, I'm going to go in here. 7 divided by 1,000. Oops, that's 100. Whoopsie. Because we're probably like, hey, you're wrong. So there we go. So it's that much metric tons divided by cubic what was it? Cubic meter. All right. So based on your calculations, how many metric tons did the water displace? So here we're going to use that formula, density, also known as P. Density equals mass over volume. So now that we have this formula, we're going to say that 1.07, whatever we got, equals whatever mass we got. So we're going to plug in whatever mass we got here into here. And that's going to tell us how much volume. So we want to figure out how much water it displaced. So we're solving for V. We're going to plug this in. So this eventually turns into the formula. Volume equals whatever our mass is divided by 1.07. 1.027. The reason why this happens, in case you guys are curious, is we have to multiply both sides by V to cancel it out. And then we're going to divide by 1.07. That way we're able to solve for this. So you're probably going to get a different answer than Edmentum's going to get based on the numbers you got. So keep that in mind. All right. So again, I would have gotten a completely different answer than this. So please do your due diligence, write your formula, and stay consistent with the numbers that you're doing. So the next thing we're going to do is we're going to use this website to use the internet to find the population. So first thing we're going to do is find the population of Ohio. This changes. So I know for a fact they're going to have the wrong number. Population of Ohio. So I'll find the population of Ohio. I'm going to say 11.63 69. So I'm going to say 11,700,000. 1, 2, 3. I'm going to say pop of Ohio, or you can say population of Ohio is that much. Then we're going to use this website to estimate the area of Ohio. So area of Ohio is, let's use this website. Your picture might look a lot different than my picture. So I need to find Ohio. Let's see here. Oh, there's Ohio. Let me zoom out a little bit more. Zoom out a little bit more. Oh my gosh. There we go. That's better. So we need to find the area of this. So in order to do that, we are going to have to click points to make Ohio. And Ohio is going to be very weird because it's not exactly oof, that looks terrible. Let me clear all points. It's not exactly a perfect square, so you might do more points than me. You might be a little lazy and do, whoa, what's happening here? There we go. Okay, it looks better now. It was very weird. So boop, boop, boop. So that's how I'm doing it. You guys might do a square, whatever, but that's what we're gonna do. So now when we look at area, we're looking at, oh gosh, how does it want? How much area does it want? It wants it in square miles. So we want mi squared. So if I do mi squared, I hate how this formats it. This is this little e is times 10 to the 4 power. So in other words, it's saying like move it 4 decimal places over. So if I did that, I would get, let me write on here. So you're looking at this, and since it says times 4 to the 10th place, I'm going to go one, oof, that's a terrible color. So I'm going to do 1 decimal place over. I know you can't see my mouse, but 1 decimal place. I moved over 1, 2, 3, and 4 decimal places over. So I'm going to get about 39,740. So this is going to be about 39,740. Yours might be different. And then again, we're going to find a density. So when we're talking about density, it's always the population divided by the area. So you should get some weird decimal. So, oh, actually, you don't get a decimal because of how big the population is. That was my bad. This is a really big number, so you're not going to get it. Your number might be different. Use the internet to find the actual area of Ohio. So now we're going to do it based on, so pop is equal to whatever we got before over actual area. So we're going to use the good old internet to find area of Ohio. Oh, and there it is. It literally gives it to us right there. The MI is miles squared. So we're going to write 44,852. So I did a lot of points, but even I was missing some of the area. I thought I would have undershot it, but apparently, or I thought I would have overshot it, but apparently I undershot it. So you're going to write down whatever you get. They actually have it pretty spot on. Well, I guess Ohio hasn't changed. So they were close with their prediction. They were closer than I was with their prediction. Ohio doesn't really change, so everyone should end up getting this number. This 48,000, 4,820. And we're going to divide that out, and so everyone should get a similar number. Edmentum has a very outdated number. As long as you show on there that you're doing population equals or density equals population over area, you should be fine. What do you think the density of Cleveland is as a city than Ohio? Well, obviously, cities should have more people, so you should put something like, I think it will have a bigger area than, or bigger area, a bigger density because it's a city, whereas Ohio has a lot of empty spaces. So write something like that down. All right, guys. Hopefully, this helps you out with the activity. Um, if you ever have any questions, again, feel free to leave a comment or make an appointment with me if you're within OFL Reseda. All right, guys, have a good one.